Can you hear what you say too?
Yeah, I can hear what you say too. So don't be too loud, but if you're goofing around, I'm going to say your name and then I'm going to send the video to your parents. Okay? Okay. So anyway, we're going to classify some of these things. So the first thing we're going to classify is a right triangle. And those are not right triangles. You can give me a definition of a right triangle. Right triangle, raise your hand. Yes. Wait. I gotta get your names again. I'm trying to get to know you. Girl in the front row, second from the right's name is Allison.
A right triangle is a triangle with a right angle.
Okay, exactly one right angle. Very nice. Okay. So a right triangle. Whoops, wrong page. I could get to the next page. I get to the next page. Okay, mine is upside down. So a right triangle is a triangle with exactly one right angle. Okay. A triangle with exactly one right angle. Okay. Right angle. That's easy. You could sketch a picture of one if you like. Sketch. What do you want to name them? That doesn't exactly look like a very good right triangle.
That's a great right triangle.
We'll call this right triangle ABC. Okay? But if it does not have a little box in the corner, be careful. Don't assume that it's a right triangle. Unless you know it's a right triangle. Wait, right. Acute triangle. So let's get the pictures of acute triangles. How do I do that? Go back here. Go back here. What's an acute triangle? Who can tell me a definition of an acute triangle? Acute triangle. What do you think there? Okay, Paige Smith.
A triangle with all angles below 90.
Very good. For a acute triangle, all angles have to be less than 90 degrees. Okay? Okay? So, yeah, they are kind of hard to draw. But an acute triangle is... Where'd my last page go? There we go. There we are. So, all angles are less than 90 degrees. Right? So, you can draw picture one, as long as you label the angles, like maybe this is 80 in here, maybe this is 80 in here, and you probably already know that, let's make it something different. Let's make it 81 or something. You come up with your, because that's another type of triangle, right? So that's 80 and that's 81, that would be 39. You know that, right? You know that already. But we won't tell you that. Okay, so let's go back to an obtuse triangle. Good. Let's look down here. Who can tell me what an obtuse triangle is? Talk about the little side block here. Yes, Sam McCrasson.
A triangle with an obtuse angle.
Can it have more than one obtuse angle?
Yes.
Why not? Yeah, and Sam said is right. You guys already know that triangles have to add up to 180, right? I think. But so an obtuse triangle is a triangle with one obtuse angle. Obtuse angle, and so you can make a picture of one. Let's see if I can do a little bit better on my drawing. Obtuse. Let's make this like that, and then like that. It's obtuse, bigger than 90 degrees, right? And so let's just call this angle up here 100 degrees. Okay? And then that would have to be an obtuse triangle. Okay? You can look at the picture. We don't have to jump back and forth. Who can tell me what a scalene triangle is? Scalene. Yes, Ellie.
Triangle where three sides are the same.
Very good. All sides are different, okay? So scalene is all different sides, okay? I'm not going to write out the full definition. So one way you could indicate something being a scalene triangle is by drawing a triangle, and if it doesn't look like it's scalene, okay, you could just indicate that it's scalene maybe by putting 1 mark here and 2 marks here and 3 marks here. That way you can ensure that whoever looks at this knows that this side is different than that side, which is different than that side, right? Okay, equilateral triangle. Who's got that one? Yes, I gotta pick a boy this time. Harrison Abel.
Regular triangle.
A regular triangle, nice, okay, or one with all equal sides and angles, right? Equal sides and angles, although it doesn't, does it have the picture in the book? Or oh, it does mark the sides and the angles, right? Okay, so that would be a good one, a regular triangle. Regular triangle, meaning all sides and angles are congruent. So I think I can draw a picture of one of those pretty easily with my special tool. Good. And an equilateral triangle looks kind of like that. And you can mark it up to put a mark there, a mark there, a mark there, and then indicate that that's congruent to that, which is congruent to that equilateral triangle. Okay? Isosceles. Oh, how do you say that? Okay. Who can tell me what isosceles is? Someone else? Isosceles. Time to participate. Okay, Stephanie. Exactly 2 sides that are the same. Okay? So a triangle with two congruent sides. And you may know already that the angles are congruent, but we're not talking about that yet. So 2 congruent sides. Let's see if I could draw picture 1. Isosceles. That's how Popeye says it. That's isosceles triangle. That's how it is. Okay.
When did Popeye ever said that?
Okay. It was in my lecture. That's okay. I don't care. People will give me thumbs up on my video. Okay. So that's isosceles. Okay. Did that sound like Popeye?
No, not really.
Okay. I don't know. Okay. So let's move on. Is that all the triangles? Yeah? That's all the triangles. So let's move on to the next page of this handout. If I can figure out how to do that. Let's see if I go like this. No, that way. How do I do that? I'm gonna go like this. I'm gonna find my page. I'm gonna go up. Okay, now we're gonna talk about some of the quadrilaterals, right? Quadrilaterals, all special quadrilaterals. Look at the pictures. Who can tell me what is a trapezoid? Yes. Michaela. With exactly 1 pair of parallel sides. Okay? So it's a quadrilateral with 1 pair of parallel sides. So you could write a quadrilateral, quadrilateral with a 1 pair, not 2 pairs, 1 pair of parallel sides. Okay? And when you draw a trapezoid, And then just use my straight line tool here. Boom. 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 And I'm going to indicate that two of those sides are parallel. You can either put one little arrow on there or two little arrows on there. Like that. Fast buddy. Parallelogram. Go ahead there, Sam Katz.
All parallel sets.
Well, they're not all parallel to each other, so how would I say that kind of? Two pairs of parallel sets. So a parallelogram is a quad with two pairs of sides parallel. Okay? And so they have, with my tool, do I have a parallelogram over here? Let's see. Is there a parallelogram? Parallelogram. I don't see it. That looks right. Yeah, but I don't want to use a rectangle. That's kind of specific to rectangle. So I'm going to try to draw it as best as I can. There's probably a better way, but I'm going to do okay here, aren't I?
That's pretty good.
Why, thank you. It's okay. So again, as long as you indicate, okay, even if it doesn't look exactly like a parallelogram, okay, as long as you indicate that those two sides are parallel by putting these little arrows on there, and those two sides are parallel, then it's good enough to say it's a parallelogram. Now you might know, like, this side is congruent to that side, or that side is congruent to that side. Yes, that's true, but that's not what makes a parallelogram a parallelogram. You understand that? Okay. A rhombus, let's see if I could use parallelogram to define rhombus. See if we can use a parallelogram to define rhombus. Go ahead there, Anna. Okay.
So is it like a parallelogram with all the sides?
Exactly. Okay, that's what a rhombus is. It's a parallelogram with all congruent sides. Okay. It can even be a quadrilateral with all parallel sides. Okay. So it's a parallelogram, or even a parallelogram. I mean, not parallel, all congruent sides. Okay. With all congruent sides. I'll try to draw one of those. There must be
A square?
no,
Well,
not
there was one.
there was. Let's see. Yeah, there's one kind in there. It looks more like a diamond, but let's see. That looks like a rhombus, right? A rhombus. That looks almost like a square, because those look like right angles, but
No, but isn't a square?
Yeah, square is
a square is a rhombus, but not all rhombuses are squares,
Square.
right?
Ooh.
So let's see if I can stretch this. No, that doesn't help. What else can I do to it? What if I squished it? No, that doesn't help. You know what? I'm going to get rid of that. Go away. Oh, sides. So I'm just going to draw it like this. Here we go. 1, 2, 3, 4. Okay. And even if it doesn't look like a rhombus, I'm going to show that it is a rhombus by going like this, 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 this. And then on top of that, I'm going to mark up that all 4 sides are congruent. So those little green marks mean all 4 sides are congruent. Okay? So that'd be a rhombus. A kite. Who's got a kite? That's kind of a tricky one. A kite. Who wants to give me a definition of a kite? Yes, Isabella. 2 pairs of congruent sides that are next to each other. Okay? So you would say that adjacent. Okay? So, hey, you're welcome. Okay, so a kite is a quad with, because like this has two pairs of congruent sides too, right? So you have to say that those congruent sides are adjacent, okay? So it's a quad with two pairs of adjacent ADJACENT parallel sides. Okay? So, not adjacent, congruent sides. Okay? Adjacent, congruent sides. So a kite kind of looks like a diamond, but if you want to indicate a kite that's not a rhombus, and I think that in our book, a rhombus cannot be a kite, okay? So those two pairs, that's a bad kite, but those two pairs of sides that are adjacent cannot be, so this can't be congruent to that. You understand that? Okay? So these are different and these are different, but these two next to each other are the same. Let's jump to square, okay? So, let's jump to rectangle. Try to use some of these other things to define rectangle. Who's going to use one of those other things to define rectangle? Yes, I'll get to know you one of these days. Reckon.
Is it quadrilateral with two pairs of parallel sides?
You know what? Yeah, but we have a quadrilateral with two pairs of parallel sides, but what's special about a rectangle? On top of that.
Oh, all right angles.
Good, okay? So you can define a rectangle as a parallelogram, okay? A parallelogram with all right angles. Okay? And I know you know what a rectangle looks like, right? I don't have to draw one of those for you, but I'm going to do it anyways. I'm such a thoughtful person. Okay? Okay? So this is a rectangle, and you could say, well, it's a parallelogram, right? But that parallelogram happens to have all right angles. I think you could even define it just, you don't even have to say parallelogram. You could just define it as a quadrilateral with all right angles. If you have a quadrilateral with all right angles, that's not a rectangle? Yeah, but a square is a rectangle. Okay? So let's try to define square. Let's try to be clever to define square. Using some of the other things that we've had up there. Let's try to be clever. Okay, I think that Sam is clever. What are you going to say? A rectangle with all congruent sides. Yes. And what would be a better way even to say that? Catherine Johnson. Yeah, I want you to just use previous figures. What do you say, Makana?
All equal sides.
What's a figure called with all equal sides? Huh? Stephanie. Oh, that would work. A regular quadrilateral. What were you going to say there, Michaela? Yeah, it's a rectangle that's also a rhombus, right? Wouldn't that be a square? A rectangle that's a rhombus. A rectangle that's a rhombus. That's a rhombus. Rhombus. And so, you know what a square looks like, I'm guessing. I think you know what a square looks like. Even my daughters know what rectangles look like. I mean squares. This looks like no, this one. Let's try a square. Now, be aware, if you see a picture in your book, okay, and it looks like this, what can you say that is?
A rhombus.
Watch, I'm going to show you what you're going to see on your quiz, so pay careful attention. If you see this on a quiz and they say, list what specific type of quadrilateral this is, what is it?
Rectangle.
Nope.
Rhombus.
Do you see any right angles in there? It might look like them, but unless there is something in there that indicates, okay? So now, if I just indicate this, like this, what shape is that? What is that? All you can say about that is that that is a rhombus. Because I might measure these angles, and they might be like 89.1 or something like that, right? They might not be exact. So unless they show you by indicating things that now it's a rhombus, and now it's a rectangle, now what does this have to be? A square, right? That is a rectangle, that is also a rhombus. So unless it says this is a trapezoid, or unless it indicates that, you cannot assume that that's what it is. You get that? Okay? So, midpoint formula. I'm going to go really fast.
Wait, what did you just click there?
What?
What did you just click there?
Oh, that's the pause button. So if I want to say, okay. Okay, midpoint formula. Have you seen this before? Okay, that should be easy. Midpoint formula. I'm just going to go real quick, do 2 problems, and then we'll be done. Is to find the midpoint of any segment, use the formula x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So for instance, say you have A has the coordinates -3. You learned this last year? That's good. And B, you're on tape. You guys can't be quiet. Okay, has the coordinates 7, comma, 1. And I say, find the midpoint. Find the midpoint. All you have to do is x, this is x1, this is x2, this is y1, y2. So you go -3. We basically take the average between the x's. Okay. Divided by 2, comma, 5 plus 1 divided by 2. So when I simplify that, I get 4 divided by 2, which is what? 2. And I get 6 divided by 2, which is 3. And that's the midpoint of that segment. Now, sometimes one more type of problem you're going to see which can be a little more tricky, okay? And that is the type of problem which says you have a one endpoint. So you have an endpoint, -1, 2, -1, wait, -1, -1, -2, and then so this is point A, and you have a midpoint at 2, 4. 2, comma 4, and they say something like, find the other endpoint. Find the other endpoint. Okay? And so the other endpoint, which we'll call B, and I'm going to call B x comma y. Okay? Because I want to know what x and y are. Yeah? Okay? So what I do is I set up 2 little equations. Okay? The first equation looks like -1 plus what? X, not plus 2, plus x, plus 2 is the midpoint. Divided by 2 equals 2. What's my other equation?
4 plus
No. -2 plus what? Y divided by 2 equals 4. Now, since I know you guys are good at algebra, I know how to do this. I'm going to multiply both sides by 2, right? I get negative 1 plus x equals 4, so x equals 5, right? And over here, I multiply both sides by 2. I get negative 2 plus y equals 8, so y equals 10. So the other endpoint is at 5, comma 10. Understand that?
Yeah.
Okay, good. Okay, your homework, which I changed last night, okay, from your assignment sheet, so it's not as bad as it was before. Okay?
Thank you.
Okay, job. Yeah, because they said, oh, that's an awful lot of homework for these guys for the weekend. So I changed it to, if I could find it, page 64, 1 through 12. Page 64, 1 through 12, which are all, I think they're all like true, false, multiple guess. And then, or true, false, and easy ones. And then 13 through 19 odd, okay? And then the stuff on midpoints is page 37, 1 through 8. Okay? So there, you do have to do page 37, 1 through 8. Book covers will be due on Monday. That line design won't be due until block day, okay? And I'm going to